when you implement a project, which usually involves many years, essentially think from the production side. We are defer the production today and using the saved resources for the future, for tomorrow. So in doing so, there's a rate of return, and this is the discount rate from the production side. Equivalently, we can also think about this in terms of consumption. So invest in a project of many years. Essentially, we are deferring our consumption today into the future. In doing so, there's a rate of return, and that can serve as the discount rate from the consumption side. Okay, let's look at this graphically. Production. So the vertical axis, let's call it today's production, today's goods and services, and the horizontal is tomorrow. If I use all resources to produce goods and services only for today, suppose I'm able to produce this many. Then I can cut the production of today by, say, 1 unit. I release some resources which I can use it for production for tomorrow. Suppose I can produce this many. Let's call this point A, point B. Okay. From point B, I'm going to cut 1 more unit for production today, and using the saved resources to produce tomorrow. And suppose I can produce this many, and that's point C. Okay, I can keep doing this many times, so I can get all these points, and I can link all these points together. We call this production possibility frontier. Okay, one important information embodied in this PPF, production possibility frontier, is its slope. Okay, let me redraw the diagram. Suppose this is the PPF, and at the moment we are at point A, which means we're going to produce this many units of goods and services for today, this many for tomorrow. Okay, then I implement a project of many years. Okay, and in doing so, suppose I reduce the production of goods and services by 1 unit today. I then release resources which can be used for production of tomorrow. So let's call this X. And then we reach a point B. So from A to B, I'm giving up production of 1 unit today in exchange for additional production of X units tomorrow. And so doing so implies rate of return, which is equal to X minus 1, so change in output, over the beginning output, 1. So it's equal to X minus 1. Okay, this Okay, I'm gonna zoom out this. Okay, so this is A, this is B, and I'm gonna call this C, and this is 1, this is X. Okay, you want to recognize that this X is actually, we can use X, or this relative 10 is actually embodied in the slope of this. So the slope of these triangles is equal to 1 over, can be measured by 1 over X. Okay, so this relative 10, or we use this as discount rate, which is production discount rate. From the production side, and this discount rate is embodied in the slope of this PPF. So this information is captured by the slope, production possibility frontier. So I hope you see it from these triangles. Okay, so that's from the production side. Let's look at the consumption side. This is today's goods and services. This is tomorrow. I'm gonna random pick one point here, which means this called this point A. This means that today consume this many goods and service, tomorrow consume this many goods and service. Starting from point A, I'm going to cut today's consumption by 1 unit, and I can save this for tomorrow. So X unit. So I got, so that I can let's look at consumption side. This is today's goods and service, tomorrow. And I'm going to randomly pick one point. Let's call this point A. That means today I'm going to consume this many goods and service, tomorrow this many. And by consuming this bundle of goods and service, I derive a certain utility, happiness, loosely. Then starting from point A, I'm going to cut today's consumption by 1 unit. And so if I do not do anything else, then you'll be less happier than before. But I'm going to say I'm going to compensate you with some units of goods and service tomorrow, so that you are the same happy as before. You derive the same level of utility. So we arrive at point B. So at point A, at point A and point B, you have the same level of utilities, same level of happiness. From B, I'm going to cut your today's consumption by another 1 unit and increase tomorrow's goods and service, tomorrow's consumption by some units, so that you are the same happy as before. So we arrive at point C, so on and so forth, so on and so forth. We can get many of these points. Link all these points together. We construct a curve. We call this indifference curve. So on every point on these curves, consumers derive the same level of utilities. One piece of information, one piece of very important information embodied in this indifference curve is if I defer today's consumption into tomorrow, say by 1 unit, how many extra units I should be compensated so that I will be as same happy as before? And this implies a kind of rate of returns, and we can use this as the discount rate. To see this, let's say we are on this indifference curve, and let's say we start from A. From A, I'm gonna cut today's consumption by 1 unit and increase tomorrow's consumption by X unit. So we arrive at point B, and I'm gonna call this C. So I'm gonna put this and I'm gonna link AB, okay, form a triangle. I'm gonna move this triangle out, zoom in so that it's easier to see it. A, B, C, 1, X. The slope here can be measured by 1 over X. Okay, so this X actually measures the slope. Okay, from A to B, the implied rate of return will be change of the consumption, X minus 1 divided by beginning consumption is X minus 1. So again, this rate of return is embodied in the slope of indifference curve. And we call this rate of return, we can use this as consumption discount rate. Okay, that's the discount rate from the consumption side in addition to the production side. Now you need to wondering which rate is bigger than which. Okay, so let's put the production possibility and the indifference curve together. So we have PPF, we have many indifference curve. Okay, so the equilibrium of the economy will be at the tangent point. Let's call this A. The economy has equilibrium at point A, where indifference curve is tangent with PPF. That means at point A, the slope of the indifference curve is equal to slope of the PPF at point A, which means the rate of return is the same. So if the economy, there's no distortion in the economy, there's no tax, then the consumption discount rate will be the same as the production discount rate.